Hi everyone, my name is Selena Berge, and today my group will be presenting our configuration management tool for Group C. Presenting will be Javier Chaparro, Sergio Morillo, Ricardo Botello, and Oscar Diaz de Leon, along with myself. Here's just a list of some of the documentation that was required in order to form our configuration tool. I'll start off presenting the first two documents, which are the work breakdown structure and the use case diagram. This is a WBS. It's a product-based WBS that includes the products that our tool offers. It is divided into four main groups: configuration or project management, user operations, the IT branch or support services, and data handling. Configuration management offers products such as change requests, assigning baselines and user permissions, and repository access, which are performed by the configuration manager. User operations has products such as retrieving backups and accessing version documents, which are functions that the user themselves can perform. The support services provide maintenance and system updates in order to keep the system going. And data handling involves external database that utilizes structured text files in order to provide easy and secure access to data. From there, we go to the use case diagram, which has similar users and functions to the WBS. It has the configuration manager, the user, the support system or IT services, and database functionalities. And also the services that are listed in this diagram are similar to the WBS. The configuration manager has access in order to provide users with certain products. Users have their own functions they can perform. Support services provide maintenance to the system, and databases provide encryptable, access-specific data.
The affinity diagram is a tool designed for managing complexity, as it facilitates the organization of a system's functionalities through the application of divergent and convergent thinking to conceptualize a system's functions, tasks, and activities. Using this tool, our team was able to organize the proposed functionalities of our configuration management system. Our major group headers are planning, management, configuration verification, organization, configuration control, budgeting, support activities, and user activities. Under each respective category, functions can be found pertaining to that particular group. Some groups represent nesting or interconnected functions with other groups. This means that those functionalities can pertain to multiple groups, thereby depicting the system's overall complexity. The stakeholder matrix documents the type of participation that stakeholders will have in the task to build our configuration management system. Using the RACI method, our team was able to define stakeholder participation by indicating that a stakeholder was either responsible, accountable, consulted, or informed for the completion of the listed task. On the left-hand side, you will find the project deliverables or activities needed for the realization of our configuration management system. These activities include stakeholder elicitation, system requirements and specifications, system engineering management plan, prototype, design, implementation, testing, production, use and maintenance, and disposal. On the right side, you will find the project stakeholders and the respective indicator for the completion of each task.
How do you read an n-square matrix? You have to start listing the system components in a diagonal line. The interaction of this component entities flow clockwise. For example, by the interaction name of A-ICT, you have the external entity of end user and component respiratory, which gives you the opportunity to manage files if you want to read, write, or delete them. The objective of a change request effects indicator is to determine how each of the requirements categories are affected by approved change requests in order to keep requirements data integrity of the system. This will help you answer how many change requests has been approved and in which category of requirements are the effects taking place the most: performance, coding, or general requirements. In this case, performance has the most approved change requests, so we have to keep an eye on why is this happening. This is done by having a data change request logs that are done every first and 15th of the months, and also by having audit reports performed once a month. These are done by the CM manager and all the management team. The display shows where the defects are affecting the requirements categories the most. This shows where the focus needs to be in order to correct the change request in that specific category. If there is too large of a number in one requirement column, more than 10% of the number of approved changes, the change request must be cancelled. Otherwise, change request may be modified.
In this section, we're going to identify the baselines with their configuration items and the criteria to release the baseline. We're going to build in the configuration management system that will offer configuration management services. This graph, we're going to identify the documents that we're going to create during the system engineering life cycle. We're going to be able to protect those documents and make them available to everyone on the team. And then we're going to identify those documents that determine the level of control, the criteria, and the document. We are dividing the baseline name, which is the analysis, concept, primary design, detailed design, build, test, deploy, and maintain control. Each of the section we're going to have with the baseline version 1, we're going to configure the items number. We're going to put as a requirement, management plan, test and specification, and the user documentation. We're going to start with everyone with the version number 1, and then after that, we're going to create the section which is criteria to release the baseline. Next, we're going to assign all of them. Then we're going to give a delivery date, and finally, we're going to put the status, publish it once we have those delivery dates. Monitoring of mitigation plans. We're going to do evaluation of the risk parameters. We're going to be observing the risks of matrix. We're going to determine the best mitigation handling methods for this description, and we're going to come up with some mitigation plan. We're going to use in this table, and also we're going to be some retentivity process that will be required weekly in order to monitor each change that may occur, each risk that are listed on the table. The mitigation plan should be included in the description of the risk, and also we're going to do some priority risk, parameters, current status, mitigation activities, and the responsible parties. And we're going to, the status, we're going to put it as a green as acceptable, yellow as a mitigation, emergency security code procedures monitor. Everyone obviously is going to be assigned to each of the parties that we already signed for responsible parties. So this is going to be our evaluation of risk parameters.
We're gonna involve decision analysis and resolution process area in order to evaluate and decide what is gonna be the best option for the system. So in this case, where is gonna be the best possible CM tool that we can use for the project. And first, we identify and we decide what is gonna be the 10 criteria that we're going to use in order to evaluate the different options. So from 1 to 10, we rank them in order of importance. So compatibility is the most important characteristic that we found, and we gave him a weight of 20. And from that, we have services provided, system reliability, software security, and file management. Those are going to be the most important characteristics that we are looking in the evaluation process. And we have some others such as CMMI maturity levels, where are going to be the support services, the user training services, additional services, and cost of services. So now we are in the alternatives evaluation process step. We have, as you can see in the table, we have different values for every criteria, and we multiply by the weight, the predefined weight, and we have 5 different options: Puppet, CF Engine, Chef, Ansible, and SaltStack. The highest score that we got is for CF Engine with 89.7, and the second highest score is for Puppet with 83.4. So the primary alternative is going to be CF Engine, and since Puppet score is within a range of plus minus 10%, we also proceed a formal evaluation process for Puppet as well. So now we are in the risk analysis evaluation process step. So we're gonna evaluate for CF Engine and Puppet, which were the 2 highest score. And we determine different conditions and different consequences from those conditions. We have probability and impact. So the range is gonna be between 1 and 5, meaning that 1 is gonna be the lowest probability of occurrence,
and 5 is going to be the highest probability of occurrence. It's going to be the same for impact, and we want to multiply those values, and it's going to give us an exposure factor, and at the end, the sum of these values is going to give you a total factor. So we have 24 as a total factor for CF Engine, and we have 10 as a total factor for Puppet. And we have an average factor, and we have an adjusted factor. So this adjusted factor is going to be subtract from the previous step, from the scores that we get in the evaluation criteria, and we want to see the results at the end. This is the table for the final evaluation. This is our final results. So CF Engine was the highest value, 83.94, and Puppet got a 81. So the risk analysis, after the risk analysis, CF Engine loses some points, some values, but even though it is still considered the best option. So we decided, after this evaluation process, we decided to use CF Engine as our CM tool for the system.